You've seen it a million times in the movies, right? The airlock door blows open, some poor soul gets sucked out into the void, and then, poof, they either explode like a water balloon or they freeze solid in a split second. It's awesome drama, it's terrifying, but is any of it actually true? Let's find out what really happens.
So, let's just get right to the biggest question of all, the one that every sci-fi movie has burned into our brains. If you were suddenly tossed out into the vacuum of space without a suit, would you really, literally explode?
Okay, so on one hand, you have the Hollywood version of events. You know the drill. Exploding eyeballs, instantly freezing, blood boiling away in your veins, all the gory stuff. But the reality? Well, the reality is honestly so much stranger and way more interesting than anything a screenwriter has ever come up with. So let's break down what actually happens, second by second. Let's start the clock. You're exposed. There's no time to think. You don't have minutes here. You've got seconds. And believe me, those first 15 seconds are absolutely critical, and they are incredibly violent.
First things first, the air in your lungs. It expands instantly and is ripped out of you. Now, if you tried to hold your breath, your lungs would rupture, which is bad, for sure, but you still wouldn't explode. Almost at the same time, the moisture on your tongue and on the surface of your eyes would instantly vaporize because there's no air pressure. And then, the big one. Within about 15 seconds, tops, the lack of oxygen hits your brain and you just lose consciousness. And that's it. Your conscious experience in the void is over.
All right, so we've established you don't explode. Check. But what about that other famous movie myth? You know the one, the idea that your blood would just start boiling in your veins? Let's tackle that one right now. Let me just be as clear as possible here. Nope. Your blood will absolutely not boil. This is probably one of the biggest misconceptions out there, and the reason why is actually an incredible testament to just how amazing the human body is. Think of it this way. Outside your body, you've got the near-perfect vacuum of space, zero pressure. But inside your body, you have your own pressurized system. Your circulatory system, your skin, your blood vessels, they're all surprisingly strong. They basically act like your own personal, organic spacesuit, and they're more than tough enough to keep the pressure inside your body stable and keep your blood in its liquid state.
So, you're not exploding and your blood isn't boiling. You might think you're getting off easy, but you're not. There are other dangers out there, silent, invisible dangers that the movies almost never show you.
We are talking about cosmic radiation. See, down here on Earth, we live under this giant protective blanket we call the atmosphere. It shields us from all these nasty high-energy particles zipping through space. But out there, in the raw vacuum, there is absolutely nothing to stop them. And the result is, well, you'd get an immediate and unbelievably severe full-body sunburn. Any part of your skin that's exposed to the sun would get blasted with a dose of unfiltered radiation that's way beyond anything you could ever imagine on Earth. And that brings us to the final, and maybe the most bizarre part of this whole story. What happens after? After you've lost consciousness, after the initial shock to the system is over? What actually becomes of a human body, just adrift in space?
Okay, so forget the whole freezing instantly solid thing from the movies. It just doesn't happen. And the reason is kind of wild. A vacuum is a fantastic insulator. See, heat needs something to travel through, like air or water. But in space, there's nothing. There are no molecules to transfer your body heat away. So you'd cool down, yeah, but it would happen super, super slowly.
So let's put all these pieces together. You have no oxygen, which means the normal process of decomposition just stops. It can't happen. The vacuum is also deadly for all the bacteria that would normally break down body tissue. You combine that with the fact that you're losing heat incredibly slowly, and you get a very, very unique situation. The result is, honestly, it's both chilling and kind of awe-inspiring. It's not a gruesome explosion. It's not a block of ice. It's perfect preservation. The body would be mummified by the vacuum itself, becoming this silent monument, a traveler drifting through the void for, potentially, millions and millions of years. In the end, the reality of what happens is so much more incredible than any Hollywood special effect.